Hello, everyone. Thank you so much for joining us today for our webinar on configuring high availability for mission critical applications in Postgres with Pgpool in PGCeres. Today, I have two wonderful speakers with me, Semab Tariq, who is the Postgres consultant in Stormatics and the brain behind PGCeres. Joining him is Muhammad Usama, who is the principal engineer at Microsoft and also a major committer of the open source Pgpool project. So, before I hand over the controls to the speakers, I would like to just go over the housekeeping items. This webinar is being recorded. You will have the recording after the session. And a few things to look into are that we have a Q&A session, so you can share your questions or queries either in the Q&A feature or the chat box of the Zoom. So yeah, that's it from my end. Over to you too. Good luck.
All right. Thank you, Annie, for the great introduction. So today we are going to talk about two important tools that are available inside Postgres ecosystem. One is, of course, Pgpool, which is used to deploy highly available clusters and provide a lot of different options to actually configure our cluster. Like it provides load balancer, it provides connection pooler, query caching mechanism, and the other tool that we are going to discuss about in today's session is PGCeres. Now, we created PGCeres in order to ease the effort and automate the deployments of highly available clusters so that you don't have to go to all the manual efforts to deploy the clusters. This tool PGCeres, you'll just need to install the tool and the rest will be taken care by this tool itself. So let's get started. So first of all, this is sort of my introduction. Name is Semab Tariq, and I'm working as a Postgres consultant at Stormatics. I started my career by joining a local company here in Pakistan with the name of Trading Icons. My first interaction with Postgres was back in 2018. This is when I joined Second Quadrant as automation engineer at Second quadrant, I was responsible for building community Postgres installers, CUDA installers, and was engaged in other customer activities as well. Then later, I joined Enterprise DB as DevOps engineer, and I continued my work. Like I was responsible again for community Postgres installer, releasing them, releasing the minor updates and adding the features. And recently, in 2024, I joined Stormatics, and I am more into deploying the clusters, performing. Actually, at Stormatics, our key focus is to perform high availability, performance monitoring, and backups and recovery solutions.
Yeah, that's about me. Nothing very special. So I'm just working for Microsoft as a principal engineer, and we are currently working on Citus. That's another distributed extension for Postgres and an open source. And you, some of you might have already tried it, or you can try it. Like it's open source and out there. So before that, yeah, I've worked in multiple companies and mostly related to Postgres. So I started hacking into Postgres since in 2007. And yeah, that is when the Enterprise DB, which is a very popular Postgres company, it was kind of founded, and I was among the very few first batch of people who joined Enterprise DB. And since then, I never looked back. Like I'm working in Postgres and related technologies, and along with that, I'm also a major contributor and committer of Pgpool, and I've committed and contributed some key features that includes Watchdog, and that's the high availability component, and dynamic spare process management, and consensus and quorum-based failover. So these are few key things which I contributed to Pgpool along with others as well. So yeah, that's pretty much about me.
Yeah, thank you, Sama. So coming back to our agenda for today's meeting. So first of all, we are going to understand what is high availability in Postgres or databases. And then we are going to see what are its different components of high availability. Then we are going to see what we are going to understand what is single point of failure, how to identify that, and how we can actually eliminate the single point of failures from our clusters. The next we are going, of course, talk about Pgpool, and we are going to talk about Pgpool, its community, and its architecture. Then, of course, I will go walk you through to code base of PG and I will walk you through how we actually can deploy that PG on different nodes. And finally, we will conclude our presentation by mentioning a couple of best practices, how you can actually configure or provision your production grade highly available deployments. And finally, there will be a question and answer session.
Okay, so yeah, so before diving any deeper, let's start with like basic building blocks of high availability and why we need high availability. I think that's pretty much understood, like why we need high availability, but just for the sake of this topic, so consider you're hosting a website or a service or an application, and you want it to run 24/7 or any set amount of time. So the only way to do that is to enable high availability, and this is very important to gain the trust of your customers, and for the business continuity as well. So it depends. For example, you land in some country and your visa card stop working, like you get stuck. So for mission critical, and even for normal application, high availability is very critical, and it's not optional, and it's something that really is critical for your business impact and continuity and everything. So yeah. uh,
Right. So I have talked about this table at many different occasions and at many different webinars and events. This table is about how we can actually measure our systems uptime in a whole year. So we actually measure our uptime of a system in a number of nines. In order to get better understanding of this table, let's see it with an example. So let's say if someone says that their system is like 99% of highly available throughout the whole year. That means if they claim 99% of high availability for their system, it means that they can expect a downtime of 3.6 days in a whole year. Now, 3.6 days in a whole year of a downtime is a huge